Okay, in this last example, we're going to find the exact length of the curve r equals 5 to the theta on the interval from 0 less than theta to 2 pi. Okay, so let's look at the graph of this. Okay, so the graph of this should look something like this. So when theta equals 0, r is 1. As theta increases, r also increases. And so it should look something more or less like this. Goes around 1 times 0 to 2 pi. Okay, so we want to find the exact length of this curve. Remember we found the arc length should be the integral from alpha to beta, square root dr d theta squared plus r squared d theta. So we need to find dr d theta. Dr d theta should be the derivative of 5 to the theta, which should be 5 to the theta times natural log 5. So natural log 5 times 5 to the theta. Okay, and the reason for this, one of the lesser known basic derivative rules, d by dx of constant to the x is going to be equal to natural log a times a to the x. Okay, and the way you get this is you rewrite a to the x as e to the natural log a x, and then you end up there. Okay, there's a little jaunt through Calc 1 again. Okay, so this is going to be the integral from 0, or alpha, our starting point, 0 to 2 pi, square root of dr d theta squared, so that would be natural log 5 times 5 to the theta squared, plus or r squared theta, so it'd be 5 to the 2 theta d theta. I'm listing. Okay, so this should be integral 0 to 2 pi. We can distribute the square across everything here. So this is going to be square root of, we'll write it as natural log 5 squared times 5 to the 2 theta plus 5 to the 2 theta d theta. But everything's multiplied by a 5 to the 2 theta, so we can factor that out and take the square root of it, because it's a square. So this is going to be integral from 0 to 2 pi of 5 to the theta times square root natural log 5 squared plus 1 d theta. Okay, so this can look intimidating, particularly that part right there, but that is in fact just a constant. It doesn't depend on theta, so we can factor it out. Okay, so factoring out our constants, so natural log 5 squared plus 1 times the integral from 0 to 2 pi of 5 to the theta d theta. Okay, so this becomes, taking the antiderivative, using similar thought process to what we did before, this is going to be our 5 to the theta divided by natural log 5 times our constant. Square root, I'll write it as, need a little bit more space. Square root natural log 5 squared plus 1. And we're going to evaluate this at 0 and 2 pi. So we get square root natural log 5 squared plus 1 over natural log 5 times 5 to the 2 pi minus 5 to the 0. 5 to the 0 is 1. So what is the exact length of this curve? You're looking at it right there. Okay, so at this point, this is the last video. Thank you all for a wonderful semester, and thank you for thank you for putting up with this distance learning, and I hope you were able to learn something. So take care, everybody. Stay safe and wash your hands. Thank you.